Structural analysis to chapter 8, deflection using energy methods. Let's solve another example in energy methods. So in this example, we want to solve a truss if the cross-sectional area of all the members are provided to be A, area is 400 millimeters squared, and modulus of elasticity of all members 200 gigapascal. Part A, we want to determine the vertical displacement of joint C. So that's CV, delta CV, because that's the vertical one. The force is not in the direction, the displacement is not in the direction of the force, so we need to use virtual work approach. And in part B, if there is no external load applied on the truss, we would want to know again what is the vertical displacement of joint C if there is no external load in part B. Only if we do know member AB is going to be 5 millimeters shorter than its current size. So let's approach our problem. So to calculate the forces at the very beginning, summation of moment for real forces, we are solving the truss for the current forces, which is the real forces. Summation of moment about A goes 0. It just gives us a by times 8 meters distance from by to A minus a 4k times distance, which is a 3 meters, and that gives us a by equal to a positive 1.5. So if by is a positive b1/2 to symmetry of the structure and also summation of forces, my bad, in summation of forces in y direction, it just gives us ay should be in downward direction, and also ax, this is a roller, and this is a pin support, and this is a roller. So for roller there is no x component, and the whole 4 kilonewton to the right should be cancelled out by ax at the pin support, which is ax negative 4kn. Then let's go to joint A, for example, here. So at joint A, we have a negative 4k in x direction, and ay is equal to a downward 1.5. You can see the joint A and the forces on that. So if this force pulling out the joint A, it should be cancelled out by a upward force like FAC. And due to the dimension of that, this is a 4 meters, height is 3 meters, this is 5, and vertical component of FAC should cancel out 1 and 1.5 downward force. So 3 over 5 F times FAC is equal to 1.5. It just gives us FAC is equal to 0.5, 1/2 kilonewtons. And if FAC is pulling the joint at A, it should pull the member as well. Do you remember, if it's just pulling, if the force of AC is the joint at A, it should pull the member by the amount of 2.5 kilonewton. So that's a tensile force. Then let's go to the other direction of let's look at the situation of point B. So if there is a upward force of B by 1.5 kilonewton, it should be cancelled out by a downward force. If it just pushes the pin, it should pushes the member as well. So this is a compression force by the amount of 2.5, the symmetry of the structure, and if you aggregate it, you can calculate it from the summation of forces about in joint B, and it just gives you a upward by should be cancelled out by a 3 over 5 of 2.5, which is or let's say 4 over 5 FBC should cancel out by 1.5. So it just gives us FBC is 1.5 times 5, or just gives us 0.5. 5 times 5 is 5. Also the direction is a negative. If you keep a closer look to joint B, it just gives you a horizontal component. This force should be cancelled out by component like 2 kilonewtons. So if it just is the joint at B, it just pulls the member as well. So we have a positive tensile force equal to 2 kilonewtons at the member AB. That's a positive 2 and tension. So right now we have all the real forces on our structure. Let's replace the direction of the by a vertical, because we want to calculate delta C vertical. If we want, we place all the points C with the 1 kilonewton virtual force. So this is a virtual force of 1 kilonewton. The direction of downward movement delta C at vertical. Let's calculate the forces. So definitely the symmetry half of the force distributed evenly distributed between supports. So if you just come to joint a 5 kilonewton upward force should be cancelled out by the vertical component of FAC, and it just says a 3 over 5 FAC is equal to 2.5, and it just gives us FAC 0.833 kilonewton. That's a push. Definitely it just gives us AX should be cancelled out by that component, and that's also 0.667, and it just gives us, if this is pulling joint A, it should pull the member as well. So this is a tensile force. It just pushes the pin. A joint should pushes the member, and that's a compression force due to symmetry. The same force applies on the other direction so far. And if we just recalculate, we created a table of all the members, and in small and capital and length of member, multiplication of all last 3 columns, and real forces structure with virtual forces, and then 1 times delta C vertical is equal to summation of n times small and capital length of member EA. So if you add up all the members, for example, if you consider AB here, real force is positive 2 capital N, AB virtual force small n points, length of that, which is 4 times 4 plus 4, 8 meters, and that gives you this number. And AC, for example, let's check CB as well. CB virtual work, CB virtual work negative 8, CB virtual real work, which is negative 2.5. So these two cancel each other, just left with 10.67 kilonewton square times meter. Okay. And if we just replace that with the new value, area of all members times the use of elasticity, it just gives us a delta C vertical is equal to 0.1. In part B, though, we want to calculate if no load acts on the, there is no load acting on the truss. We want to be interested to see what is again the vertical deflection at point C, the vertical downward move C, if member AB is 5 millimeters shorter than the current time. So again, only member AB undergoes a change in length. So we just have a DL of point negative 0.005 meter, which is 5 millimeters. And yet you can solve with the virtual work method. You can have 1 kn vertical delta C vertical downward and calculate the virtual forces, which is the same like part A. The only differences here is this time calculate the forces of AB times delta L, which is 1 kN times delta C vertical is equal to 0.60 AB. This is A, this is B. If internal force of AB is 0.667 kilonewton times delta L, which is a reduction of change in length, which is delta L, and it just gives us a delta CV for part B is equal to a negative 30. Thank you. Solve more problems on virtual board.